Hello everyone. In the last class we studied about the interior of the earth. Some things were left out, so I'm covering those things here. There are high chances that you may get a MCQs on these questions. The first thing is, what is the earth made up of? What are the elements of which earth is made up of? The whole earth is made up of iron, which is highest in percentage. 35% is iron, then 30% is oxygen, silicon is 15%, magnesium is 13%, and nickel is 2%. Okay, so the trick I use, the mnemonic which I use to remember this is IOS man. I stands for iron, O stands for oxygen, S stands for silicon, man, Ma stands for magnesium, Ni stands for nickel. This is the order in which you are supposed to remember it. They may ask you which has the highest percentage of element in the whole earth. This is one question that can be framed. The second question that can be framed is, what is a important elements in the earth's crust in percentage wise? The highest is oxygen, then you have silicon, then aluminum, then iron, and you have calcium, sodium, potassium, and finally you have a magnesium. So this is the whole earth's crust and this is the whole earth. Make sure that you don't get confused between these two orders. IOS man you can remember for whole earth. Then the other important topic which we could not cover in the last video is lithosphere. We have covered that it is a crust plus uppermost mantle. Asthenosphere is a upper mantle, but we didn't cover the other things like lower mantle. It is in a solid state, outer core it is in a liquid state, inner core it is in a solid state. So if you started from here, then it will be like solid, liquid, then you have solid, semi-solid, and then you have a solid state. Okay, this is one more thing which I felt it's important to be covered. They may ask you like a lower mantle, it's in a solid state or in a liquid state or semi-solid state. So it's in a solid state. That's the one more thing you should remember. So now let's start with our fourth chapter, that is distribution of ocean and continents. So this is a very important thing. Just a minute. Yeah, so see, the first thing that the first MCQ which can be framed from this chapter is distribution of ocean and continents. They may give you a match the following, and there are mainly four theories in the distribution of ocean and continents. Before going to these theories, let's understand. We all know that what is a ocean and what is a continent. Continent is that part of a crust where we live, and ocean is that part of a crust where there is a water, right? Ocean, we have mainly 5 oceans that all of us know. We'll study more in detail about these 5 oceans once we start about the world geography. Okay, yeah, so this is the ocean, and then this is a continent. Okay, so now there are different theories given by different people about the distribution, how the ocean and continent are distributed. The first theory was given by continental drift theory, that is given by Wegener. They may ask you this thing like continental drift theory is given by, they may give you the match the following. They may give you options like Wegener, Arthur Holmes, Hess, Mackenzie, and Parker. So you have to know that continental drift theory is given by Wegener. The second theory is convectional current theory. It is given by Arthur Holmes. Then seafloor spreading theory is given by Hess. Plate tectonics theory is given by Mackenzie and Parker. We will study about what are these theories in detail in next few minutes. First, get to know that just make sure that you know these things when they are given in the match the following. So what how I remember is, see, sea floor spreading, this starts with S, right? So Hess, it has 2 S. Okay, that's how I remember. Then the next one is convectional current theory, right? So convection sounds similar to like convention hall, something like convention, right? So convention, that's how convention, homes, these are like home related things. So I remember it that way. You can remember it any way which you like to be. Then convectional current theory is related to Arthur Holmes. Then continental drift theory, Wegener. Plate tectonics is given by Mackenzie, Parker, and Morgan. So now Um, just remember these four things and the theory given by each one of them. So now let's start with first theory, that is continental drift theory, given by Wegener. So what Wegener said is, just a minute. So according to Wegener, all the continents formed a single continental mass and a single ocean surrounded the same. Like, let's see in the picture here. See, Wegener said all continents, they form a single continental mass and the only one ocean surrounded them. He called this mega continent as Pangaea and this ocean as Panthalassa. Okay, the blue water, okay, the ocean is Panthalassa. Then later he said that this supercontinent was broke into two large continent masses as Laurasia and then Gondwana land. Okay, so Laurasia and Gondwana continued to break into smaller continents that exist today. A variety of evidence was offered in support of this continental drift theory by Wegener. So this is how it broke into Laurasia and Gondwana, he said. Then it started breaking into different smaller continents, and then this is the present day world map which we see, right? So he said that it was first like large continent, then large water body, Pangaea, Panthalassa, then Laurasia, Gondwana, and then you have a present thing. They can ask mega continent that was formed, that was there before, that is named as Pangaea, Panthalassa, Gondwana, Laurasia. That's Pangaea, right? Mega continent is Pangaea. Okay, this is how he thought. And the reason why they are breaking into a smaller parts like this was given by him. What he said is, see here, you can see it. He said the reason for this drifting is pole fleeing force and tidal force. Pole fleeing force means what? He says that we know that this is a north pole, then just a minute, yeah, this is a south pole, right? So he said that these continents are moving towards the pole. That's the reason they are breaking into a smaller parts. The other reason, what he said, is tidal force. What does a tidal force means? See, there is a ocean, right? Here it is, it is applying some force between it's pushing the one continent on the one side and the other on the other side. So there is some tidal force which is acting. That's the reason these continents are drifting together, sorry, drifting apart, right? That's the reason he said that. But these reasons were criticized by other people and they gave their own theory. Okay, these are the reasons given by Wegener. And what is the evidence that in support of continental drift theory? If he has said that these continents are moving apart, like they're moving far from each other, then with on what basis? If you tell something, there should be some reasons given, right? So on what reasons? He gave 5 reasons. First one is jigsaw fit. See, what he said is jigsaw fit. See, if you could, the present day South America, if you try to jigsaw fit with Africa, you can see it here. So it's like we play with a jigsaw puzzle, right? So it's the same way. It's like fitting perfectly. The South America and Africa are in a perfect jigsaw fit, is what he was telling. And the other reason, what he said, is rocks of same age across the ocean. So if there is a one ocean body, just a minute, say there is a ocean 1 and there is some other ocean 2 here and there is some continent here, then the rocks of same age, say the rocks of this ocean age, the rock age, rocks of same age across the ocean, this rock and this rock are of same age. Then he gave the third reason is about tillite. What is tillite? Tillite is basically a rock. What kind of rock? Sedimentary rock. We'll study about what is sedimentary rock, other types of rocks in our next chapter. Just know that tillite is a rock. It is formed by deposit of glacier. Say there is a mountain and there is a ice. So when the ice move down, it will form the deposits, right? So it will form some deposits here. So tillite is a rock formed out of deposits of glacier. Okay, just remember, what if they ask you in an exam, like for 1 mark question in prelims, say tillite. What is a tillite? It's a rock formed by glacier. If they say it's a deposit of water, no. Alluvial soil, most of us know, right? We'll study it in our Indian geography in class 11th, second book, that is physical environment. Just know that what is a alluvial soil. Alluvial soil is a formed by deposition of water. In the same way, tillite is a rock formed out of deposits of glacier. Make sure that you remember tillite. Whenever the word tillite comes in an exam, it's related to rock and it's related to deposits of glacier. These two things you're supposed to remember. Okay. Then next, let's move to the placer deposits and then distribution of fossils. So placer deposits means what? Say here there is a mountain, okay, and there is a flow of water here. When the water comes down the hill, it carries some amount of minerals with it, right? And it deposits here on the plain area. So, say you found a gold in this particular place in the plain area, then there should be some source, right, from where this gold has been carried. But in present day, in Africa, Ghana, we find a gold, but there is no source from where did it come. That's the placer deposit. So there is no source of from where that gold has been come from. So the placer deposits means what? The source from where things are coming, that's the placer deposits. Then distribution of fossils. Fossils means what? They those are the remaining of animals, dead animals. Distribution of fossils. Say there is an animal called X, which is presently found in Asia. The same animal fossil is found in South America. How is that possible? Because there is a huge ocean in between, right? This could be possible if it was like in this image. Like, see, if this was the case, then they would have moved freely here. But right now there's a huge ocean. That means at one point of a time, all these places were connected together. Is what Wegener gave the reasons, but these reasons were not accepted by others, and they gave their own theory. We'll see about those theories now. So now we are done with first theory, that is convention. Just a minute. Why is this pen not working? Yeah, it's working. So we are done with continental drift theory. Now we'll see convectional current theory given by Arthur Holmes. See, it's very simple. What do you mean by convectional current theory? So what did Arthur Holmes say is the reasons um, the reasons for drifting given by Wegener is not right, but it is true that continents are drifting apart. So he said that the reason why these continents are drifting apart is due to convectional currents operating in the mantle portion, and these currents generated due to radioactive elements causing thermal difference in the mantle portion is what Arthur Holmes said. Say, let me draw it here. Say, consider this as a plate of earth. Consider this as a plate, okay, of a earth. So what he said is there are convectional currents acting in the mantle portion of the earth. So here you have seen, right, this is the mantle portion of the earth. So there are currents which are acting in this mantle portion. That's the reason they are moving these plates apart. Just a minute, I'll draw it in a clear way. Yeah, see, consider this as one continent. Just I am showing it for the easier one. This is another one. There is convectional current. Convectional means moving upwards, okay. Upward current is moving, which is of magma. So that's the reason these plates are moving apart. That's the reason given by Arthur Holmes. You need not remember, you need not know in detail, just know that convectional current theory is given by Arthur Holmes. Convectional current means current which is moving in a upward direction is convectional current. Then now we are done with second theory as well. Now let's move to third theory, that is seafloor spreading. Harry Hess gave a seafloor spreading. What till now all these discussions was going about the continent drift. How is continent? We have not talked about sea like oceans. He said that there is even the sea floor is spreading. Say this is a continent, right? He said that at first this was the condition, then he said that after some time the sea floor has been spreading. So it's like this, just a minute. So it's like sea floor is also spreading in this way. So the extra water, I know this is a green color, excuse me for that, it should be blue. So yeah, now it's fine. So first condition was this. Then now sea floor is also spreading is what Harry has said. And he gave the facts about why this sea floor is spreading. The volcanic eruption common along the mid-oceanic ridges. He said that the reason why this first sea floor was say this much. Then now after few, not few years, like lot many years, the sea floor has become this huge. So why is the reason? The volcanic eruption is common along a mid-oceanic ridge. We'll study about mid-oceanic ridges in our oceanology class, which we'll be taking in next few classes. We'll study about the mid-oceanic ridges there in detail. Okay, just know that volcanic eruptions is one of the cause for mid-oceanic for seafloor spreading. Okay, then the second fact that Hess gave is rocks on either side of mid-oceanic ridges show similarity. Okay, let me explain mid-oceanic ridges here only. See, just a minute. I'm so sorry, just a minute. Give me a minute. I'm searching if I could find any picture which shows the mid-oceanic ridges. Yeah, sorry, I couldn't find any pictures which shows a mid-oceanic ridges. I'll explain mid-oceanic ridges in oceanology itself. We have full we will study about this in detail. So next let's go to the third fact, that is ocean crust is younger than continental crust. So see here, this is a continental crust, we know, right? We studied in the last class as well. This is the ocean crust. Ocean crust is younger than continental crust. Okay, why is this? Can we guess that? Yes, not guess, that's the fact. See, ocean, right? There are volcanoes which are taking place even now, since even on earth it's taking, but the volcanic eruption in oceans are more recent than the continental crust. That's the reason ocean crust is younger than continental crust. This one can be one of the MCQs. They can ask, is oceanic crust younger or a continental crust younger? oceanic crust is younger. Then the fourth fact is sediments of ocean floor are thin. Since the ocean floor is spreading, the sediments of the ocean floor are thin. And the fifth fact is trenches have deep seated earthquakes, mid oceanic earthquake focus have shallow depth. The earthquake, we studied it in the last class itself. See, when there is a earthquake, there is a point inside the earth that is known as focus, also known as hypocenter. Good. So that point is deep seated in the trenches also we'll study in the oceanology. Then mid oceanic ridges earthquake focus have shallow depth. We'll study about trenches and mid oceanic ridges in oceanology class, where you'll get a clear idea. So I would say it like keep this whole thing sea floor spreading for ocean. Let me keep this, I'll explain this again concept in oceanology in better and more diagrammatical way. So let's now go to fourth concept, that is plate tectonics. It's given by Mackenzie, Parker and Morgan. So what they said is, they said that, as Wegener said before, that the continents are drifting apart. But what plate tectonics say is, these plates have been constantly moving over a globe throughout the history of earth. It's not a continent that moves as believed by Wegener. Continents are part of plate, and that moves is a plate. So see here, he said that these continents are moving apart is what Wegener said. But plate tectonics says our earth is made up of plates. Here you can see in the image, it's given even in an NCRT book. There are plates, like see, Eurasian plate, this whole thing is Eurasian plate. Then you have a North American plate, then Caribbean plate, South American plate. Different plates are there. These plates are moving and continents are placed on these plates. So they say that uh, it's not a continents are moving, instead it's a plates which are causing these changes. Okay, and when the plates move, you have a convergent boundaries, divergent boundaries or transform boundaries. So what does a convergent boundary means? See here. Say this is a plate 1, then this is plate 2. When these two plates converge, move towards each other, then crust is destroyed. But if these two plates move apart, then the crust is created here. And if they move transform, like they don't clash with each other but they pass by each other, then crust is neither created nor destroyed. So this is about the plate tectonics given by yeah, Mackenzie, Parker and Morgan. So we are done with the fourth concept as well. So I hope this is clear to you. Sea floor spreading, we will look at it in oceanology, don't worry about that. So I hope you are clear with these concepts. Make sure you can get in a prelims, match the following for these four things. Which theory was given by whom? That's one thing. And Pangaea, Panthalassa, they can ask like what are those. Pangaea, Panthalassa, you have seen here, Pangaea is a vast landmass and Panthalassa is a large water body. That thing can be asked. Then convergent boundary, crust is destroyed or it's created or nothing happens. When converge, crust is destroyed. That thing you have to remember. In diverge, crust is created, and in transform boundary, crust is neither created nor destroyed. That one thing you need to remember. And yeah, that's what you need to remember in this thing, distribution of ocean and continents. And yeah, one more thing, very important thing that you need to remember is 90 East Sumatra orogeny. I'll write it here. 90 East Sumatra orogeny ridge is present in Indian Ocean from where India started moving. They can ask from which point did India started moving. It's 90 East orogeny. You can remember this as well. 90 East Sumatra orogeny ridge is, there's a ridge present in Indian Ocean. So see, if you see it in a diagram, say, yeah. So in Indonesia, you can see Sumatra. So from here, Indian plates started moving. Okay, so that this is all about a distribution of ocean and continent. Thank you.